Hello, hello, hello! Welcome back to another maths video from OXB Maths, the out-of-the-box mathematics series. So in this video, we're going to talk about quadratic expressions and how to solve them. So let's start with our classic quadratic. Y equals ax squared plus bx plus c, right? So you've probably learned in school, if y equals 0, what's x, right? And you've probably been taught that the roots, solving for y equals 0 is known as finding the roots of the quadratic expression. You've probably been taught this famous formula, negative b plus minus the square root of b squared minus 4ac. Right, today we're going to show you a different approach, right? So instead of using these expressions, we're going to rewrite this expression as y equals ax squared plus 2amx plus an. All right, now bear with us. This looks a little bit strange, but the great result is that if y equals 0, x equals, you get this very neat expression, which is m squared minus n. So it's the roots of your equation. Instead of having this horrible fraction here, you get x equals negative m plus minus square root of m squared minus n. Okay. Now that's a lot neater than the traditional b squared minus 4ac, and it's got some neat properties as well. So for example, if you were to try and plot the graph, okay, of this quadratic equation, so let's assume a is positive, so you get an upright parabola like this, kind of. The midpoint here is always negative m. That's kind of handy. And the roots of this equation, which is the roots, the point at which the graph intersects y equals 0, that is always negative m plus minus that quantity. Okay, so let's call that plus. Let's call that m squared minus n. All right. And one further property that you can extract from this is that the lowest point or the minimum value of this expression is negative a into m squared minus n. So there's no square root here. What else? What else can we see? Okay, well, I think that's about it. Let's give you a concrete example of how you could use this to plot your standard parabolas, standard quadratic equations. So let's give you a simple one. Let's say y equals, I don't know, let's say 3x squared, let's say plus 12x, let's say minus 36. Okay? Now how would you use this new technique? Okay. We would use that new expression, y equals ax squared plus 2amx plus an. So let's just rewrite the whole thing, just to make sure we don't make any careless mistakes. 2amx plus an. All right. And from that, you can obviously see that a equals 3. That's pretty easy. You can also see that 12 is equals to 2 times a times n. So 2 times a times m is equal to 12. Remember to take into account your signs. It just so happens that both are positive here, so that's fine. So from this, you can see m is equal to 2. Pretty easy. And finally, you have an, which is 3 times n, equal to negative 36. And n is obviously negative 12. There you go. You've got your a, you've got your m, and your n. And from that, you can tell that your roots are negative m plus minus that expression. So let's compute that expression first. The square root of m squared minus n is equal to 2 squared minus negative 12, so that's plus 12. So 4 plus 12 is 16. Square root of 16 is obviously 4. Okay, we're only taking the positive root here. So what do we have? The roots of the equations are, okay, if y equals 0, then x equals negative m, which is negative 2, plus minus that expression, which is plus minus 4, and that's negative 6 or positive 2. Okay, you can use this to very easily, very quickly plot a graph. So you've got your x-axis over here. The parabola is that way because the x square coefficient is positive. If it was negative, your parabola would be kind of upside down. So let's do that. The midpoint is negative m, which is negative 2. Don't forget the negative. And your roots are negative 2 plus 4 and minus 4. So negative 2 plus 4 is positive 2. Negative 2 minus 4 is negative 6. Right? So your parabola kind of looks like this. Let's see if I can draw this correctly. Well, kind of. Right, that's supposed to be symmetrical, but you know, that's my freehand parabola there for you. Now, the x equals 0 point is there, obviously, between negative 2 and plus positive 2. So that's your y-axis right there. So the parabola looks like that. Okay, so let's fill in some numbers and check that our sketch is correct. The bottom point here is, as you can recall, it was negative a into m squared minus n, which in this case is negative 3 into square root of m squared minus n is 4, so the square of that will be 16, which is negative 48. So that bottom point here is negative 48. You could have got the same value by substituting x equals negative 2 into this expression, right? So negative 2 square is 4, 4 times 3 is 12, 12 minus 24 is negative 36 minus, what was I doing? 3 times 4 is 12, 12 less 24 is negative 12, negative 12 less another 36 is negative 48, right? It's a little bit clumsy, you know, if you knew that the property of this parabola, which is that the minimum is just that formula, okay, you can get the answer pretty quickly. All right, what else? What else can we do? Let's consider the y-axis intercept. Okay, so when the graph crosses the y-axis, what do you have? X is obviously equals to 0, right? So substituting x equals 0 in here gives you y equals negative 36, and that kind of makes sense, right? Negative 48 is about 12 away from negative 36, and that's 2 away from the y-axis. Take another 2, that increases up. So that's basically a property of parabola. It sort of increases exponentially. All right, so that's your very simple sketch of the parabola. Now, just for fun, if you had used the traditional b squared minus 4ac formula on this, what would you have? Remember, it's negative b, so we have x equals negative b plus minus b squared minus 4ac divided by 2a. And if you substitute all these numbers in it, you would have got negative 12 plus minus, oh boy, 12 square minus 4 into a, which is 3, into c, which is negative 36 divided by 2 times 3. Okay, good luck with that. That's a little bit messy. You can see that this approach, which is the m and n approach, is a little bit neater for this specific example. All right, so I hope that's useful. This is just a different way of reducing your quadratic equations. Thanks for watching. Hope you can use that in some of your exam questions, and and surprise your lecturers a little bit. All right, have fun, and we'll see you in the next video.